Right now, your tongue is running chemistry experiments, thousands of them, every second. You think you taste 1,000 flavors, you don't, you taste 5. 5, that's the whole language of taste. Sweet, salty, sour, bitter, and one that took nearly a century to confirm. Everything else you call flavor, that happens in your nose, not your mouth. Your tongue holds roughly 10,000 taste buds, replaced every 2 weeks. Each bud is a tiny rosette of cells, listening for chemicals. So why only 5, and why might there be 6? For centuries, scientists believed taste was infinitely complex, beyond counting. Then came a German psychologist obsessed with measuring the senses precisely. In 1916, Henning proposed a taste tetrahedron with 4 basic qualities. Sweet, salty, sour, bitter, every flavor, he argued, lived inside that shape. This 4-taste model ruled textbooks for almost 100 years. But a Japanese chemist had already found a 5th. In 1908, Ikeda was savoring a bowl of kelp broth, dashi. It tasted savory, deep, satisfying, but it wasn't sweet, salty, sour, or bitter. He took the broth to his lab at Tokyo Imperial University. He boiled down kilograms of kelp, hunting the source of that taste. There is a taste common to asparagus, tomatoes, cheese, and meat. The molecule he isolated was glutamate, an amino-acid. Ikeda named the taste umami, Japanese for deliciousness. He patented his discovery in 1908. Ajinomoto, the seasoning empire, followed a year later. That glutamate became MSG, the white powder in millions of kitchens. But the Western world refused to believe umami was real. For 90 years, umami was treated as a myth. Scientists demanded proof, an actual receptor on the tongue. The mouth needed a physical lock that glutamate fit like a key. The proof arrived in the year 2000. At the University of California, Zucker hunted for taste receptors. His team mapped the proteins that catch each tasting molecule. In the early 2000s, researchers identified a true umami receptor, T1R1 and T1R3. After 94 years, Ikeda's 5th taste was finally proven real. And the same teams crushed another myth you were taught in school. The tongue map said sweet at the tip, bitter at the back. That famous map is completely wrong. A 1901 German paper was mistranslated, then printed for decades. Every region of your tongue tastes every flavor, there are no zones. Each taste sends its own signal to your brainstem and cortex. Bitter is a warning system, many poisons taste bitter to your tongue. Sour signals spoilage, rotten and unripe foods trigger that pucker. Sweet means energy, sugar promises calories your ancestors craved. So each taste is really an ancient survival instruction. Salty guides the minerals your body needs to function. And umami, it tells you protein is present in your food. But here is the twist, 5 may not be the final number. A 6th taste candidate is gathering serious scientific evidence. At Purdue University, Matt studied how we taste pure fat. In 2015, his team identified a distinct taste they called oligustus. It's the taste of fatty acids, separate from creamy texture. The tongue may carry a fat receptor called CD36. Other candidates are lining up: calcium, metallic, even carbonation. Some scientists argue starch itself has its own taste. The map of taste is still being drawn. What we call flavor is mostly smell, memory, and texture combined. Your tongue contributes just a handful of pure notes. Your brain composes the rest into a single experience. Pinch your nose, eat a jelly bean, the flavor vanishes, only sweetness remains. That tiny experiment proves how little your tongue actually does. Next time a meal moves you, thank 5 quiet messengers. And listen closely, a 6th may be whispering already.